Now, so far, all I've really talked about is how you take something that is a package that you signed and you know you want to distribute and get it out to the users. Now, I'm going to pull back a little bit and talk about a whole software supply chain and focus on what this looks like. So this looks kind of similar maybe to something like your software supply chain. Maybe yours is a little more complicated, but I hope you'll humor me for a moment, where you have some kind of repository, maybe a Git repository, and you do some static analysis and linting and stuff like that over your code. You build what comes out of your signed Git tag here and pull in dependencies maybe to do different things, and then you fuzz and do analysis on it, and you package it and send it off and so on. Localization, and I'm ignoring some, a few steps in here, but this should look pretty familiar. So for the moment, for this talk, to not make this like too long, I'm going to simplify a few things. First of all, I'm just going to take all this testing stuff that happens and just say there's something testing, okay? And I'm going to assume you all know how to test your stuff better than I'm going to be able to tell you to test it, at least, right? I would hope so, because it's very domain specific and so on. The other thing is that I will talk about dependencies, but I'm going to leave this out for later. So right now, we're going to just drop down and imagine that our software supply chain looks like this, okay? And this is actually a big problem. Attackers can go and break into different parts of the software supply chain. And there are many, many instances of this happening. So people break into version control systems, like the FSF, which has Apache and all these other very high-profile projects. The FBI or possibly the NSA broke into OpenBSD's IPsec stack. Juniper's VPN was backdoored by the NSA. The Linux kernel source code repository was hacked, and so on. So this has just happened time and time and time again. Like, it's just repeated. Okay. People have also broken into build systems repeatedly. There's issues where Apple has had with people breaking in and like distributing misbuilt area things of this. There's a Fedora example I talked about before. BSD has a problem, and then SolarWinds is the big one that everybody knows about, where Russian hackers go and they break into a build system, and they install a Trojan that waits for them to do a build, and then at that moment replaces a single file with a backdoored version so it gets built in, and then removes it from the file system immediately afterwards in a completely invisible way. So it's super, it's like super smart the way they did it, and was very hard for the team to find. So this is, scary stuff. Okay, and then there's also a bunch of issues with the packaging part, and I already talked about these before when I was talking about all the problems that of companies that were broken into through their package manager. So I'm not going to beat that one to death. And then finally, for testing, there are actually a lot of situations where big companies have had problems with testing, and a kind of fun example of this is one that happened with Windows a while back, where they pushed an update that mostly went to update servers serving places like Kazakhstan. And Kazakhstan has not the best human rights and surveillance record, right? So when Microsoft pushed an update that only seemed to go to Kazakhstan and a couple other countries, people were very suspicious that this meant that Microsoft was intentionally letting Kazakhstan backdoor their users in some terrible way. But they said, no, it was just a mistake we made. Sorry. And then 2 weeks later, they did the same thing with different countries. So maybe it was actually a mistake because they may have screwed up twice, But yeah, so this happens, and it's happened to Apple and other companies like that too. So it's not, unbelievable. So hackers can and will and have broken into all sorts of different parts of the software supply chain over time. So now, how can we fix this? Okay, so there's many good point solutions. So when you look at what should you be doing on your version control system? Well, you should, I assume everyone's probably using Git. You should sign your Gits and tags that uses our code and stuff like this. Only push to production your tagged releases. I'm going to talk about, I put a little asterisk here because I'm going to come back and talk about how you make sure this actually happened later. Like, you can't actually do this with just what I described. And you want to use hardware tokens on your developers if you can to try to, so that you have some assurance that people who are signing your code are actually, or producing your code are actually who they say they are. Because a lot of times, there are a lot of things you can do with breaking into repos and so on. You want to actually enforce your code review policies, enforce branch access control. And there's a great blog post I put here by someone who did a group that did a very detailed integration of all of this that talks about all the pain points they had and how things went and so on, if you're interested in more information. So you can kind of solve your version control issues maybe 70 to 80% of the way of where they need to be by doing the steps described there. Okay, now let's take a look at what you can do in the build system. So there's all these things we know about, TPMs, HSMs, stuff like this. So good approaches, there's this thing called reproducible builds. Who here has heard of reproducible builds before? Okay, so many of you, but not everybody. So it's this idea that you can take a piece of software and build it potentially on 2 different systems and end up with an identical copy of the software. And if you think that just sounds like it should happen anyway, then you're probably like most people who haven't tried to make things build reproducibly. But there are actually a lot of things that go into the binary that you produce that that make it vary. And so even things like the type of file system it's on might cause the order in which, when you ask what files are in a directory, they're returned, and that can cause like a linker to link things in a different order, or other things like this. There's just a whole bunch of different things that vary here. So if you can, you would want to have independently managed build systems of different operating systems that are both fully patched but are independent. Build your software and then cryptographically verify that they're the same. And what I mean by that is, don't just have like one of them take the result from the other and then only continue if it's okay, because what if that one was compromised, or what if the other one was compromised? So you want to, once again, think about a situation where one or more of your build servers is compromised. That's why you're doing this in the first place, right? So you have to have a smarter way to verify, and I'll talk about that smarter way in a little bit. Okay, so TPMs, HSMs, and things like that are good. They're nice to have, right? It's good to have that kind of stuff, but it's not sufficient, okay? It's like, like a firewall. A firewall is a good thing to have to protect your networks, but it's not the be-all, end-all for security. Once you put up a firewall, you don't just stop caring about anything else. All right, and if you're doing provisioning in the cloud, you can use projects like Spiffy, which is another Linux Foundation project, things like that, to provision things. And there's a keynote talk here that was given. I think this is actually SolarWinds talking about how they changed their software supply chain to add reproducible builds and in toto and other things like that after their hacks, so that it will never happen to them again. But it goes through quite a detailed description of a lot of these points. All right, so now we have packaging. I don't really have to talk too much about this because I've already talked about all of this. But there's a couple of entries here. Use TUF, Uptane, or this is a popular cloud TUF implementation that's done by Docker folks. Okay, and then one thing you might have heard about, who's heard of software bill of materials? Okay, also quite a few of you. So this has become a big buzzword because what this basically does is it basically describes all of this here, right? And that's important because right now, when you get a piece of software, you basically, it's like, back in the olden days in America in like the 1800s, you would buy Dr. Kapos's magic elixir, right? And who knows what's in it? It's probably heroin, but there's something in there, right? Okay? And you had no idea, right? And that's where we are today with software, right? You have no idea what's in your software, but you're just sort of okay. Now, if I go, buy something in a supermarket today, it has a list of ingredients, right? If I buy a drug, it tells me what's the active ingredients are and how much, and there's all these safety protocols. And so software bill of materials is kind of like that. Now, wouldn't that be nice? Is that solve the problem? Well, let's see here. So no, it really doesn't, okay? And so there's a lot of reasons why it doesn't. One of them is that you don't know that the thing that you built when you build your code is actually a tagged like release out of your system. You don't know that the thing that got packaged was the thing that you built, right? There's no verification for any of these, like that this process was followed. You don't know that the thing that you're going to run was the actual thing that was tested. And if you just have a single box that is supposed to track and do things, it's not going to be able to tell you all of this. You need something that effectively tracks and validates and presents cryptographic metadata for these steps. And also, you can put anything you want in software bill of materials, right? It's just a file. So wouldn't it be nice if you actually had some reason to believe this is accurate? Okay? And this is actually something that we were shouting about the time the executive order was coming out, because there were sort of two camps. There was the camp of, let's make everybody do SBOMs, and then there was the camp of, let's make everybody do something like SBOMs. It could be SBOMs, but let's make them actually signed and mean something. And unfortunately, the camp of let's just do SBOMs was the thing that was required in the executive order, but now everyone that I know is in the, oh, we made a mistake and we should have signed things camp.